Alrighty, then welcome everyone to the second community meeting of this year in February. In the very beginning, the organizational stuff, as always, the community meetings are reported and they will be later uploaded to YouTube as well. The slides will be published to our community repository over on GitHub. We would like to ask you to use the Zoom chat if you have questions while we are talking. Maybe also to my fellow colleagues, if you find anyone who raises their hand or something while maybe I'm speaking or someone else, then please just let us know so we can take questions as well. And of course, as always, there will be an open Q&A towards the end where you can ask questions to us, like to the core team or even to each other in the audience if you want. The agenda for today is first, I will go over the past and upcoming releases of Dependency-Track version 4. And then we will have, it's sadly on the agenda right now, we have Mikael, who will present about how Dependency-Track is used in his organization. Afterwards, I will present about vulnerability database updates. If you followed a few of the past community meetings, we talked about our desire to have our own centralized vulnerability database. There is some progress there. I will share that progress in a minute. Towards the end, a little bit of an update on Hades. I will also give a sneak peek of an upcoming feature or an upcoming change in architecture, if you will, if we have time for that. And then, as I mentioned, the open Q&A towards the end. First, for the past and upcoming releases, starting with the past release, which was version 4.12.3, a bug fix release, which was released on January 27th. The primary thing about this release is the fixing of GitHub advisory mirroring. Essentially, before that version, we had a problem that we were getting rate limited by GitHub's API. The API has a secondary rate limit, it's called, where every few requests you get a GitHub signals to you that, hey, please wait for a minute and then do follow-up requests. We did not honor GitHub's request there. So the mirroring would fail before it could complete fully. So now we do honor those rate limiting indicators, and we also switched the mirroring to be incremental. So even if it fully fails halfway through, the next time it runs, it just picks up where it left off, essentially. There were also some fixes for notification alert testing, like the test button in the UI that wasn't working for the Jira notifications. And we also had the problem that certain check constraints in the database were outdated if you use Dependency-Track for a longer time, and we updated check constraints over time. In some instances, those were not automatically updated. That was also fixed now. And there are like more small minor bug fixes as well in that version. For the upcoming releases, we already have a version 4.12.4 planned. This is just mostly out of habit if new bugs are reported that are easy to fix or that are already fixed in the next major version. We just backport them per default now so we can push out bug fixes sooner to the community, essentially. 7 small fixes are already backported, and the release will happen soon-ish or soon. For version 4.13.0, I would like to refer to the previous meetings as well, where last time we had, for example, the presentation about collection projects from Ralph King, who contributed that feature. That will be coming in version 4.13.0. But we will also have to drop some of the planned issues from the 4.13 milestone. Otherwise, this will just like never release, I fear. So we will drop a few things during the next days. What is still pending and what we definitely want to have in that version are summary notifications, which also Ralph King contributed, and there's a pull request for this already. Also, since last time, new contributions came in. One was for mirroring of vulnerability data from PHP Composer repositories. They have a kind of interesting model in how they distribute vulnerability advisories. So this might be coming in the next version. And we also received a contribution to make API keys more secure. And I will talk about that specific thing more specifically. So in version 4.12 and earlier, API keys had the format prefix, underscore, and then the actual key. For example, this would look like this, where the prefix is ODT for owasp-dependencycheck, underscore, and then like random gibberish for 32 characters. This is stored in clear text in the database. It is always visible to admin users. So if you go to the Teams overview in your admin panel, you can just see all the API keys for every team. So in the next upcoming version, the API keys or new API keys will have the format prefix underscore public ID underscore and then the actual key, which would look something like this. The only thing that is added here, obviously, is the public ID. The hash or the key part of this is hashed. It's stored as a hash in the database. It's SHA-3256 hashed. And the full key is only visible to you after you created it. If you navigate away from that page, it will not be visible to you anymore, and you cannot see the full thing. The public ID part will be visible in logs. So if someone fails authentication with that key or whatever happens with that key, you can search by that ID in your logs, essentially. And also functionality that needs to address specific keys. For example, you can add comments to a key in the UI. They will also, those keys will be addressed by the public ID, essentially. So you have no need anymore to provide the full thing. Obviously, there will be a migration necessary to enable this. So what we will do is we will hash the existing key during the existing keys during the migration. We will mark those keys as legacy, and we will highlight them as such in the UI, so that when you navigate to the admin panel again, keys that have the old format will show up as such. The old keys will continue to work though. So if you have any integrations right now that use the old API keys, you do not have to do an entire switcheroo or turn services off or whatever. You can just upgrade and be fine. What we will do essentially in the background is we assume the first 5 characters of the old API keys to be the public ID. So if there are any endpoints that need the public ID, we will just extract it if we need to. Of course, the downside will be because the keys will be hashed. You cannot see them anymore in the UI, even if they are the legacy keys. So one thing you will have to do is, if you need them in full, before you upgrade, go into the admin panel, write them down, store them somewhere safely, and then upgrade so you do not lose access to them, essentially. And of course, we will encourage everyone to just regenerate the keys, right? I mentioned we will label or we will highlight the legacy keys as such in the UI. So obviously, you are encouraged to generate new keys and delete the old ones. That is the migration path forward. And this was kindly contributed from Thomas or Gepard Game on GitHub. So thanks so much for contributing this. Before I move on to another topic, I would just hand over to Mikael, if that works for you, Mikael.
Absolutely. And I will, as mentioned, I'll try to keep it as short as possible in order to save time, because this was kind of squeezed into the agenda right now due to
no worries.
Due to reasons. So I will start by sharing my screen. Just 1 second. Sharing the host disable participant screen sharing. Zoom says.
Oh, let me just get you as a co-host. Make co-host.
Yeah,
you should be
notification.
Awesome.
Yeah, now it seems to be working, I think. So
yep.
I will start this presentation right now. So the title of this presentation is Dependency-Track at WirelessCar. And to just, of course, ask the first question, because everybody knows what Dependency-Track is. What is WirelessCar is probably the question. It's a company founded in 1999. It provides services, connected vehicle services for the automotive industry. We were bought by Volkswagen in 2018, and yeah, due to the nature of the services that we provide, we have a high and ever-increasing focus on security. We have a dedicated open source program office The head of that office is actually present in this meeting right now. It's Daniel. So far, we have only managed to create 2 pull requests for Dependency-Track, of which one was merged, and they were both addressing the same issue, but in slightly different ways. And I guess this is the typical scratch your own itch scenario, which I think is quite common in the open source world. Now, how do we use Dependency-Track is of course the main topic. It's in production since roughly mid 2022, so almost 3 years soon. We try to always run the latest version, although we currently had to revert to 4.12.2 due to issue number 4595, which I think was related to creating projects with something with tags, null pointer exception, something. I don't remember exactly. But yeah, you can look up the number of that issue. We have integrated Dependency-Track with our CI/CD system. So for each CI/CD build, we run the Cyclone DX generator, CDXGen. We run both CDXGen and Sift, and then we actually merge those SBOMs before we upload them. And some numbers then. We do roughly 6,000 CI/CD builds per day. The number of API requests to Dependency-Track is something about 100,000. When I looked at the database, we had 285,000 projects in the database, of which 4,500 were active. This is just pure numbers from the database again. So 53 million rows in the components table, which corresponds to roughly 38,000 distinct component names and 280,000 distinct component versions for those that are interested in such numbers. And we really appreciate Dependency-Track because it has provided a huge value to the company. So we are extremely grateful for having access to such a great tool. But there's always a downside, of course. There's always a positive and negative side of things. So wait, what happened now? There it is. We have some challenges. Due to the nature of how we use Dependency-Track, we have a quite fast-growing database, which leads to degradation in performance. And we also have, we have problems with memory leaks and daily crashes, basically. And the reason for this is probably some part of some method that loads all the contents from some big table, serializes it into Java objects and fills the heap. And that crashes the JVM. But the workaround, we handle it by auto-scaling in AWS, which at least can make us sleep during the night. But this would of course be nice to avoid. Now, so we have created this just from the top of our minds, things that we would like to see in Dependency-Track at some point. Maybe we could work on them ourselves even. First and foremost, then is the stability. And there's also someone came up with the use case where it would be nice to be able to know in which historic interval we have been vulnerable. So basically, not only getting the information of whether we are vulnerable now, but also how it was historically. And someone mentioned that it would be nice to integrate at some point with clearly defined for licenses. So these are things that we perhaps would could start working on providing pull requests for, unless someone else already would like to do the same thing, of course, or already started on it. But let's see. That's about it, I think. And that was quick, 6 minutes. Good. Do we have any questions?
Just one quick thing related to the scaling problem. I'm trying to build a platform around the dependency-track, and I've solved that problem putting an Elasticsearch in front of it. So majority of the queries, they go straight to Elasticsearch, and that solves that problem.
Okay. Yeah, that sounds like
Could be something that maybe you can adopt, perhaps.
Sure, absolutely. That's something we could look into. And I think I talked to Niklas at some point about the this tendency of, I mean, it's a common development pattern for Java projects in general, I think, or many developers maybe. It's very simple and easy to do a select star from table, and then you iterate through the result set in memory. And I think that is what's crushing the JVM right now. But yeah, we still haven't pinpointed it.
I would fully agree with the analysis of this. I also sounds reasonable that this is the pattern that causes the memory leaks. To be honest, I wasn't quite aware that this is such a big problem. So yeah, you would definitely prioritize that, I guess. If you have any hints as to when this happens, maybe at which time intervals, maybe we can pinpoint it to which asynchronous task is causing this, because we have been trying to weed out all of these issues over time. But of course, stuff keeps popping up. So if you have any hints for that, that would be much appreciated, of course.
With me coming from as a long time Postgres database user, I would probably look to the stats. What is it called? PG stats something. There's a tool that can basically tell you exactly. I mean, you set the login level, so you see, first and foremost, you start logging all the queries. And if you see anything that does select star from some table, and then you will of course also see which table, and that maps to some Java class. And then you can just look for where is that Java class used in the persistence layer, and that probably could point you to the point where it's where the problem is. That's one way to address it, I guess.
Yeah. Sounds reasonable. Vinod, you're raising your hand.
Yeah. Hi, Michael. Yeah, thanks for the presentation. The question is, have you tried Hades yet? Or if you have any feedback or anything on the Hades side?
Yeah, so we actually tried, we did quite an early, I guess, a little bit too early POC, proof of concept with Hades. And someone would have to correct me on the timeline, but I think it was, could it be in August, September previous year, 2024. And I think we just at that point we concluded that it was too early. The exact reason has slipped my mind right now, but we concluded that it's going in the right direction, but it's not mature yet for us to run it in parallel to the classic version. I think that was the outcome.
Sounds like a more than fair assessment. Yeah. Yeah.
You would have to take into account that this was probably, I mean, since then, which probably was September maybe, a lot of things have happened since then. So if we would do the same proof of concept tryout right now, we might come to other conclusions.
if you plan to do another POC, I would encourage you to wait a little bit more because we're just on the path of ripping out Kafka again. So I hope that should also simplify things a lot when you try next time.
That sounds like it would simplify a lot of things, definitely.
Yep. Do we have any more questions for Mikael, maybe?
It would be interesting to know if someone else has, I mean, what kind of size people are, let's say, and what kind of usage people have. I mean, are we unique in this manner, or are we typical? I don't know. It would be interesting to know how do other people use Dependency-Track. What issues do they have, and do we have?
Hey, Michael,
Yeah,
it is me again. I have a similar use case, actually. It is about half of the size that you have. And remember that I've encountered some problems in some sequential operation about comparing probably the NIST vulnerability with the data set of package URL. And I remember it was suffering in this operation, the Dependency-Track. I don't know if you have observed something similar on your side.
I think so. Yeah. In general, when it comes to performance issues, we usually address it with creating additional indexes to support the queries, creating some more exotic kind of indexes. But yeah, for example, for like queries, I think that you need to use special indexes for those, for example. But
One very quick question. Yeah. Oh, sorry.
No, go ahead, please.
A very quick question this time is, what do you use as application version? In my case, after a lot of scan and imports, I'm relying on short hash of the commit, and perhaps with the latest release, I can add the version as a tag. The reason is that the same version, same var of the application, is going to override the same record, and I'm going to lose the previous history. Instead, if I keep commit by commit, then I have more granular control over what gets pushed.
Ah, well, that's interesting. I don't think we have encountered that issue, actually.
I mean, if you update your code base, removing everything, you are removing information. Now, going back to your wish list, where you want to find where some component was running back in the past. Well, in that case, you have just lost that information.
True. Yeah.
On that wishlist item, when you said component there, do you really mean like components on the like package level or on the project level? Like, do you want to see if log4j, like when was log4j in my project vulnerable? Is that the wishlist item?
Yeah, I think that is the use case we want to support. So basically being able to know, yeah, taking log4j as an example, knowing which versions of log4j were vulnerable, and knowing, for example, I mean, we might have upgraded log4j now, but for a period of time we did use vulnerable versions, and then the question might be, okay, during what time frame should we look at logs for patterns that exploits the vulnerability, for example, and then such a query would be useful.
Yeah, it sounds interesting.
A small note, so, if I may. Oh, sorry, Nicholas. Please carry on.
Thanks so much. So in that use case, would you want like to know which specific vulnerability was affecting that component at one time, or would it be enough to know it was vulnerable at some time? Like how granular would this need to be?
No, I think the input should be the vulnerability, the CVE, and the output should be a time, like an interval. So from the date, hour, minute to start and stop. I mean, in this time frame, this project used that version of that vulnerable library. I think that's the desired functionality.
Sounds reasonable. If there is not an issue yet, would you mind maybe creating one on GitHub so we can like discuss further there?
That's a very good idea, and that's of course how it should be handled, because without an issue, it doesn't exist.
Right, but still good to have it discussed. Valerio, you said you also
yeah, just a quick add, going back to that Elasticsearch. If I have an index document for each ingestion, then I have also a timestamp. That helps me to have a time series of how a certain component evolved. So going back to your wish list, where was log4j active in my platform, then I have the exact data point. Or when this component was introduced, like a birth certificate of a component, and how it evolved. This is one of the perks.
Yeah, I mean, I think the data is there. I think so, in the database, in the schema. The missing part is probably only, I mean, like a query or an API method to construct the query towards the schema to generate the response, the desired response. I think so, but yeah, it's only once you start looking into the details that you know for sure.
Maybe a birth certificate would be a nice add in the Dependency-Track. Maybe a wish list for the future.
Before we move on, Valerio, your setup sounds very interesting. Can we get you to somehow document like how you set it up? I think it would be of interest for many others as well.
Oh yeah, absolutely. To extend the problem of Mikael, the actual answer that I want from log4j is to detect where he is located, coming from. That is not enough. Also to add some context, and the context is where that log4j is running. Yeah. Then I can have kind of actionable insight that they go end to end. That was it.
Yeah, all good. Do we have any other questions before we move on? Doesn't seem like it. Then thank you so much, Mikael. And please let's keep in touch for the memory leak stuff, because that doesn't sound so good.
Sure, I will. Yeah, let's keep in touch. Let's keep in contact.
Awesome. I will reshare my screen. Alrighty. Yeah, if you followed the last few meetings, we were talking about this vulnerability database effort that we had going on. Actually, last meeting, I mentioned that we were looking at other efforts similar to this. There's vulnerable code from the NextB folks. There's GripeDB from the, not Sift. What's the company name? Anyway, so the Gripe and Sift tooling folks have their own database. Trivy has its own database. So there are existing efforts going on that we could feed from. But there was some research necessary to see if they are a good fit for us. And we looked at a few of them and came to the conclusion that we cannot use any of them as is. This is mostly because most of them are optimized for one-shot CLI tools. And what I mean by this is those tools don't necessarily care if if one version of the database is replaced with another version of the database, and there are differences in the data between them, right? They can fix something, roll out a new database version, and everything is fine. With Dependency-Track, because it's a long-running process, we cannot just like have vulnerabilities vanish from one day to the other. We need to do a bit more tracking, and then what changed, who changed it. So we have a bit more tracking going on. So these one-shot databases don't really work for us. And also because we want to like source from multiple databases like the NVD, GitHub advisories, etc. We need to normalize all their data anyway. We need to move them all into one place anyway. So really the biggest task we have is data quality research to know what sources we can trust and that we can roll out with confidence, if you will. We don't just want to throw data into one database file and then roll it out and have everyone experience inconsistency issues or implausibility issues even. So we had some research tickets open, but of course it's kind of a big ask to just look at other databases, see if it fits the project without having something to start from. And research itself is obviously not the most fun thing to do. So what we decided now is we will just put something out, some proof of concept, where people can look at the setup, at how we pull in data, how we normalize it, and then probably doing research on that data if they want, extend it if necessary or if desired. So there is this repository on the bottom right. There's a QR code. It's currently pointing to one of my own repositories. The plan is to move this to the Dependency-Track organization shortly. The links here will continue to work because we will simply transfer the repository, and GitHub should redirect, should just redirect if you click on those links. I would like to walk you through what we currently have and explain how it is intended to work and how it may work in the future. With everything I'm going to say in the next few minutes, keep in mind this is just a proof of concept. Nothing is set in stone. And if you have any input or any opinions on any of those things, please just let us know. Help us to make this good. This is literally just to put something out, to have something to discuss about. But the overall concept, it will be quite similar to what Gripe and Trivy and others are doing, for example, is to import the data from all the sources that we care about. In this case here, it is GitHub, the MED, OSV, and possibly others. We will import those into separate SQLite databases. We can do this in parallel or however we please. And this is useful for like we can cache these databases separately and we can update them separately. If GitHub fails, it doesn't impact the MED import and so on. The next step would be merging of those databases into one. In this step, the data is still isolated by source. I will go over the data model in a few minutes. So in this stage, there will be duplicates in the database essentially. The procurement step would be looking at the data we have from all the sources and then picking what we want to distribute to users or to Dependency-Track instances. For a simple example, GitHub has GHSA advisories or GitHub advisories. The NVD has CVEs. Can we correlate them in the useful manner? And if they have potentially conflicting ratings, like their CVSS scores may be different, can we somehow pick the best of them or the most fitting or whatever have you? So this is really about analyzing the data, trying to find something we can distribute and essentially minimizing the database, for lack of better words. At the end, there could be an enrichment step. This is where we could add, like, if the vulnerability is present in c-scrm, where we can add the EPSS scores, we can like flag false positives or remove false positives, add false negatives. Add version ranges so we can avoid false negatives. Valerio, you're raising your hand, please.
Yeah, I've been there. I've done this exercise already. So what I've stopped at some point, but remember that the aggregation in my case was an object, CNAs, and then it was a list of objects, and then each object scores severity of each CNAs. And the other thing is that I remember that OSV already includes GitHub. So OSV might already suffice for all the scores that you might want to fetch from GitHub. And I think that GitHub has also some throttling protection. So probably I would bet on OSV, which also includes the NVD as aliases. So it already has some interesting data set.
Yeah, for sure. There is large overlap between the sources for sure. Yes. But to my knowledge, OSV does not include all GitHub advisories. Like they have this pre-selection of ecosystems that they support. So you have some vulnerabilities that are present in GitHub, but not OSV. And then, yes, OSV has like aliases to CVEs, but the CVEs and the NVD have CPEs instead of only pearls. And the NVD also includes hardware vulnerabilities, for example. So the bottom line really is like some of these databases have a lot of data, some of them don't, and some of them overlap, but some of it doesn't overlap. And even between GitHub and OSV, despite their data in principle being the same, or I think OSV sources from GitHub, sometimes there are still differences in that data as well. I don't know if they enrich something or if they just lag behind sometimes. But I will go over how we would like to analyze the data we're collecting here in a few moments. But it's definitely a good point. This is, yeah, there is large overlap.
To my knowledge, they are OSV is lacking a little bit behind GitHub. Just the other day, I've opened a pull request because there was a critical, for example, it was missing on OSV. But I would add another thing, which is the most important information that you can get from OSV is the fixed versions. That is a list. And that probably in future is going to replace the latest version in Dependency-Track, because it gives you a lot of options, not just the latest, which could be a breaking change, but even the closest to where you're coming from. And that is the most valuable thing in OSV.
Yeah. That, and then the inferred information of, is this already fixed at all, right? I think tools like Trivy, that you can set, please do not show me vulnerabilities that are not fixed yet. Like there are these types of filters that Dependency-Track currently doesn't support. But by like rethinking our solution, we can hopefully bake these in as well.
Yeah. Don't know if it does a filter. Basically, I've worked with the APIs. But yeah, that information is a very good start. I can tell you what is missing is that you don't know whether or not the version that is going to introduce that fix is going to also open the gate to other vulnerabilities. Yeah. That is something that needs to be expanded manually.
Maybe we can, I guess that is a good question if we can do something in that direction as well. Something to be researched. Okay, I will just move on from this for now. The proof of concept that we put out, or that we will be putting out, is shame on us. It's currently written in Java, but it's not set in stone again. It's just so we can, like, we could start quickly. All you need to do to import or to implement a new source, to import new data, is just implement this importer interface. It gets handed a database interface, and that database literally just allows you to pull or to retrieve source metadata and to store source metadata, and then to store vulnerabilities. The source metadata is used for incremental mirroring. So, for example, GitHub advisories. If for whatever reason the import fails halfway through, it can still persist the last updated timestamp for a vulnerability that it saw. And then the next time it runs, it can pick up back from where it left off. Essentially the same how it works in Dependency-Track now, just like locally with that database as well. And the entire synchronization stuff from the upstream data to the SQLite database is behind this database interface. We currently have, just to get started, GitHub, NVD, and OSV importers, so that already works. Surely there are some bugs in that, but at least the foundation is there. Also, same thing as you probably have seen this from Gripe, Trivi, whatever. We can do these imports in GitHub Actions, and there are some example workflows in the repository right now, where we just import the raw data from the upstream sources and then merge them together, and then upload the databases individually as GitHub packages, which you can then download via tools like ORAS or maybe also Crane, I don't know. But every tool that can interact with the container registry can also download from GitHub packages. For the data model, this is currently quite minimalistic. I hope you can somewhat see the individual entries, but at the top you can see there's a source table and everything is mapped to that source. So the intention behind this is that we want to normalize the data from the upstream sources, but we still want to know where it came from. And this is mainly for research purposes. I will go over that point in a few moments. But the entities, if you will, that we have here are vulnerability aliases, vulnerability data, vulnerability ratings, vulnerability references, and then matching criteria. The reason for normalizing it like this and not using like JSON documents like OSV is doing it, or even GitHub advisories, is that this makes it a lot easier to correlate this data and compare it in a SQL database and with SQL tools, if you will. So there is a vulnerability or a vuln table at the very bottom. It only has one column right now. It's the ID. The intention behind this one is this should be data that everyone agrees on, that literally never changes. The ID is currently the only one that I could come up with, but if there's something else, for example, the namespace of the ID, if necessary, we could add it here as well. And then all the sources can contribute data, for example, the description, the CVEs. They can contribute ratings or references like URLs to advisories or whatever. And then obviously matching criteria. And matching criteria is just which CPE or which Perl is vulnerable to or is affected by the vulnerability. And we also would like to take into consideration that some vulnerability databases have additional criteria. For example, the Go vulnerability database, which is also included in OSV, they provide imports that are vulnerable or that are affected by a vulnerability. So if, for example, you were to upload a BOM with reachability information or with call stack information, we could use this data to like check if you're actually affected. So we try to take that into consideration as well. For the versions, like there's only one versions column in this entity right now. We would like to use verse, which is also under TC54. That's the same organization or the same working group that's also dealing with Perl, like with package URL. I will show you a few examples of how that looks in a moment. This is actually a snippet of the matching criteria table that I just showed. Here you can see on the very left side the source that reported this specific thing for the vulnerability or for a specific vulnerability. Then here are the Perl type, the Perl namespace, and the Perl name, and then the versions. And the versions, as I said, these use the verse notation. A nice thing of the verse notation is that it also indicates the type of comparison or the way of comparison you should be using for that range. So if you can see here, for Debian vulnerabilities, there's this verse : deb prefix, and that tells the analyzer, hey, this is a Debian version range. Please follow version comparison rules of the Debian versioning scheme, and so on. And this will definitely help us to like reduce false positives or false negatives due to failing version matching, which is a problem that we currently have, to be honest, because at the moment we try to do version matching just on heuristics or on a regex basis, and this is too error prone. It's never going to reliably work. But with verse, we have better chances of this being reliable in the future. Just to mention it, you may see some URL encoding in here, and that is because verse ranges are literally URLs. So if there are special characters in here, they are encoded. It is up to the application later on to decode this and then do the comparison. Then, as I mentioned, the additional criteria, I mentioned the Go imports. Here, I'm just like showing the data that is provided by OSV. The idea is that we like take the data as is, but we have a discriminator here that tells whoever is using that database, hey, this is the type of data that you have to expect here. And then the analyzer can do whatever is necessary to work with this data. I don't think it would be a good idea to somehow normalize this in like a common data format. I think that is an exercise that will probably not work in the long term, because every database will likely use a different format, and we cannot account for all of them in finding good abstraction. Again, just initial thoughts. Now for the research part, one thing we struggle in Dependency-Track a lot with is aliases or vulnerability aliases. You will have seen this countless of times. There's CVE reported by the NVD, and then there's also a GHSA reported by GitHub or by OSV. And that GHSA says, hey, I'm an alias of CVE so-and-so. The problem that we currently have is we cannot reliably deduplicate based on this data. And we also don't know, like later on, which source reported which alias, and was that alias correct? Did they correct it later on? Was it like removed later on? Like what? The things that can happen to an alias are kind of a blind spot for us right now. And the confidence of alias relationships being correct is also quite low. I did some initial research even like 2 years ago, and the meaning of alias is kind of not what it should be. I will show an example in a few moments. But what this data allows us, by just importing all the importing the data from all sources separately and having all the separate data lying around in the same database, it allows us to do analysis on which source reported which alias for which CVE in this case. This is an example output of such a query. And here we can see which, like for example, for CVE 2025 24814, there are 3 aliases. OSV reported 2 of them and GitHub reported 1 of them. The GHSA alias of GitHub and OSV line up. So you could say we have a higher confidence that this is correct because multiple sources reported it. But OSV also reported this bit something alias, which probably no other source would report. The hope is to kind of get an idea for which source is reliable when it comes to aliases, which source isn't, and if we can somehow deduce from the data at hand automatically what we can rely on and what we can ship to users eventually. Because what we definitely want to avoid, and this is the alias concern that I have mostly, situations like this where you have one Go vulnerability in the middle that claims to alias multiple GHSAs, and the GHSAs then claim to alias multiple CVEs. In this case, you can not reliably say, if I ignore one of the GHSAs, I also want to ignore all of the others, just because they're aliases, right? The alias relationship should be transitive, and it should be bidirectional. If those 2 things are not true, you cannot deduplicate based on aliases. It just doesn't work. So what I really want to do is, before we ship like any sort of alias grouping to users, we need to really make sure that situations like this do not happen. We do not want users to suppress things that should not be suppressed. And we also do not want to report duplicate metrics or metrics that are too less because we deduplicated too much, essentially. And hopefully by having this data in the SQLite database or wherever else, we can build data quality checks in our pipeline right? For example, if there are more than 2 GHSAs aliasing a CVE, then like this is not really transitive, right? Those are not really aliases anymore. So better not ship this as an alias group, or even do not claim that they are aliases at all, if that makes sense. Yeah, so automatic sanity checks would be good for stuff like this. Finally, if you want to help with this, and I really hope we can get more involvement in this year, implementing more importers. I mentioned we currently have 3, but there are multiple more sources. For example, Amazon Linux advisories, Red Hat Oval feeds, the Chinese National Vulnerability Database essentially exists as well. I think there's a European database on the way as well. If we can somehow get all of this data in and start analyzing what is good and what is not, and what we can ship, that would be great. So yeah, more. The generated databases I showed before, we published them to the GitHub package registry already. The repository has instructions on how to download them, how to open them with DuckDB, for example, or with SQLite browser. Just download them, look at them, see if you can find any interesting patterns that can help us. If you can see any obvious issues or errors or whatever else, that would be super helpful. Mark, you're raising your hand.
Yeah, hi. Sorry, one question. Why is OSS index not there?
Because OSS index cannot be mirrored. You can only request pearls ad hoc.
Reason why I ask is that I saw vulnerabilities today being reported by OSS index against prime faces, which are not reported by GHSA. And the reason is because the vulnerabilities are in jQuery, which is packaged by prime faces. So I want to know about it, and it's only OSS index which tells me about it.
Yeah, that's a good point. I guess if we were interested in that data from sources that only allow ad hoc vulnerability checking, what one could do is prepare a list of pearls, of package URLs that are known to be vulnerable, then request that data from OSS index, for example, in batches, and still import it. There are some, obviously, OSS index would probably not tell you which version range is vulnerable, so you kind of have to either imply that somehow or just omit it entirely. But it's not impossible to include that data in the comparison, if that's what you're asking.
Actually, it does. I had to use the UI to work it out, but it quite clearly shows me that the version of prime faces that I've got is vulnerable, and the next version is vulnerable, but with one less vulnerability. And it shows me from a certain point on, like 2 versions, 3 versions later than what I've actually got, there's never another vulnerability from then until the most recent version of prime faces. So OSS index does actually give you the version range that you actually need.
They give you that information in the UI, but not via API.
No, I didn't say that they don't give it in the API. I said I found it via the UI.
Yeah. I just want to, clarify, I guess.
Yes, I don't know. I basically I think that the API is crap because it does stuff like it doesn't they just delete stuff and give you a 404 error instead of a response to saying this vulnerability was removed because it was rejected. It just deletes it.
Mhm.
So the API has got limitations, but when I went through the UI, I could actually see what was going on for jQuery, or rather sort of prime faces, which I happen to know contains jQuery, and what I need to upgrade to address the problem.
Yeah. I guess that's their main business model, right? The data itself, not the API.
But that should be the main business of pretty much anyone who's in that market nowadays, be it Black Duck or whatever. It's not just, you know, offering a sexy UI, it's a quality of the data.
Yeah. Alrighty, just finishing this off quickly. As I mentioned, you can download the database already. They are, or the instructions for that are in the README of the repository. Or here's the direct link for that. Also contribute to the data model, like Valerie already said, knowing the fixed versions or if something was already fixed or not would be nice to have or would be essential to have in the data. So this is currently not accounted for, but it should be in there. If you have stuff like this, let us know, create an issue, create like a pull request or whatever, discuss with us. That would be very helpful. Also, one idea to just test if the data is actually any good is to just build a simple scan command, right? Give me a bomb and I will check with this database if there are any vulnerabilities in it. It's a very good smoke test for the data quality, I think, because ideally what you get out of this tool, you should get out of Dependency-Track as well. So if we can find a good algorithm to use this data to swiftly and accurately report data, this would be a big win. And we can experiment with this outside of Dependency-Track, safely isolated so we don't impact users while we try to improve. Yeah, direct link. And the next thing would be an update on Hades, but we're already at the hour. I would propose I will move this to the next community meeting then, because this would also include a demo. Yeah. Do we have any questions for today still before we close the meeting? I didn't check the chat. Okay, it doesn't seem like it. Okay, then I would say we call it quits here. Thanks everyone for joining. Thanks so much, Mikael, again for presenting, and hope to see you next time. Bye-bye.
See you next time. Bye.
Thank you.
Thank you. Bye.
Bye. Thanks.